problem 2 basically asks us to find the frequencies of different piano keys or tones, or notes, excuse me. So the first part asks us to find the frequency of middle C. So in order for you to understand how this works, you either have to have some understanding of music theory, or you have to know how to use Google. So to find the frequency of middle C, if you want to do it mathematically, which I assume this is what this assignment's for, we use the frequency of piano using the nth key formula, and that's here. So you have f of n equals 440 times 2 to the n minus 49 over 12. That can be also written a different way. It could be 440 times the 12th root of 2 to the n minus 49. But I prefer this way just because it's easier for me. But I actually found that after putting it into my calculator a bunch of times, it was easier to actually do the 12th root because my calculator wasn't really liking me doing complex algebra, and at least sort of complex algebra into an exponent. Anyway, so all you have to do is plug n for the key that you're looking for in here. But how do we know what the key n is? Well, if you just Google it on Wikipedia, you can find what key number correlates with which note. So you have different notes, and then you have their octave associated with them. And then if you weren't familiar with piano, then you'd have to figure out by reading up here where middle C is. And here it tells us that middle C is highlighted in cyan, and A above C, as it's stated in the problem, or A440, which is called that because it has 440 hertz frequency. We'll find out why in a bit. It's highlighted in yellow, and so if you scroll down this table, you can go ahead and see that there's yellow for 440 and cyan for middle C. So now we can start the problem. So now we know that middle C is key number 40, so that's what we're going to use for n. Then we're just going to plug it into our formula here and put it into the calculator. So what you end up getting is 2 to the 40 minus 49 over 12. And then that's 440 times 2 to the negative 9. Okay, sorry. And then you just plug that into your calculator. You end up getting 261.66 hertz. And then you do the same thing for A440. Of course, we right now only know it as key 49. You plug 49 in here, you end up getting 2 to the 0 over 2 to the 0, and 440 times 2 to the 0, of course, is just 440 times 1, and you get 440, which is why it's called A440 or A4. Cool. And then the next part of the question asks, what is the frequency of the lowest note on the keyboard? And is there a way to solve this without simply computing the frequency of every key below 220? So I don't really know what that question is asking, other than just coming here and understanding that if you subtract 13 point something every time, then you're gonna eventually get to the lowest key. But the short answer is yes, you can find the lowest note by using n equals 1 over here and plug it into your calculator. And what you end up getting is 440 times 2 to the 1 minus 49 over 12, which after you do the math equals out to 27.5 hertz. And then the last part of the question, which is the Bosendorfer piano, is famous due in part to the fact it includes additional keys to the left-hand end of the keyboard, which is the lower end, extending to the C below the bottom A on the standard keyboard. What is the lowest frequency produced by a Bosendorfer? So, in order to be able to solve this problem, you have to have some sense of music theory again. But I've made this easy to understand, hopefully. So this is going to be bottom A, or the lowest note on a keyboard. And then the notes on a music scale go from A to B, C, C sharp, D, D sharp or E flat, E, F, F sharp, G, G sharp, A. And I understand that's probably not really important. All you really need to really know is that the C below it is going to be this many down. So I ended up just writing the notes backwards, G sharp, G, F sharp, F, etc. until I got to C, and then figured out what key that was. And that turned out to be -8. So I went ahead and just plugged -8 into our formula to see if that spit out a frequency that was about right. I got 16.35. This is all in hertz. 16.35 hertz as the frequency for the C below bottom A on a Bosendorfer piano. I went ahead and checked it with Google, and there seems to be some a little bit of variability here, based on the fact that I don't think anybody really uses those notes, but 16.5 seems to be the consensus, and that's pretty much as close as you can get without getting into very specific exponents of 2. All right, thanks.